Wow.
How do we know Earth spins? Firstly, the Foucault pendulum. As the pendulum moves backwards and forwards, it's asserted Earth rotates underneath. So in 24 hours, the Earth must rotate 360 degrees, which is 15 degrees per hour, which is what we observe in gyroscopes, right? Both mechanical and fibre optic. As the gyroscope appears to stay rigid in its reference frame, the Earth rotates underneath at a rate of 15 degrees per hour. But the most famous assertion of Earth's spin is...
I did a quick calculation and I tweeted. The winning field goal in that game was aided by a 1/3 of an inch deflection to the right from Earth's rotation.
Mind blown! So let me get this straight. Someone kicks a ball, but because Earth is spinning underneath it, it will appear to deviate. So following that logic, there must have been some massive spin under this ball when it was kicked. I mean, look at this. He kicks it over to the right, and it comes back to the left. Amazing! And some players can even make the ball deviate both ways. Haha, I know this trick. It's across the equator, right? Because things deviate in opposite directions, either side of the equator. This goalkeeper had no idea of the Coriolis effect. Got him a beauty! But wait, what is the Coriolis effect? There are two constituent parts. The first being a rotating reference frame. In this assertion, the globe rotates. The second part being the inertial reference frame, which is everything not attached to the rotating reference frame. This can be demonstrated better by a drone on a roundabout. The drone leaves the roundabout of the rotating reference frame and enters the inertial reference frame. From the rotating reference frame, it appears that the drone is deviating. Movement. But we can see that the drone is not moving at all. It's the rotating reference frame of the roundabout moving underneath the drone. An apparent deviation. The two reference frames, highlighted by the green, the rotating reference frame, and the red is everything not attached to the rotating reference frame, the inertial reference frame. So every observation from the rotating reference frame is Coriolis, an apparent deviation. But from the observation of the inertial reference frame, if something is moving, this is not Coriolis. This is an actual deviation. So to observe Coriolis, we need to be attached to the rotating reference frame. And we need something to leave the rotating reference frame into the inertial reference frame, like this drone. It appears to deviate, but it's not moving at all. So if we actually live on the asserted rotating globe, that means everything that leaves the rotating reference frame should appear to deviate, because it's in the inertial reference frame. But these hot air balloons are moving in every direction possible, kind of behaving like gas particles, moving freely and randomly in all directions. If it is asserted that the Earth rotates to the east, then everything in the inertial reference frame should deviate to the west. But that's not what we observe in reality. Let's look at other things in the inertial reference frame, like helicopters. They hover for hours in the air, and the Earth should be rotating underneath. They should be experiencing a deviation to the west. But as we can see with this helicopter, it can make precision movements, which is why it's used to stand this high voltage tower. But once again, in reality, we never see this helicopter deviate to the west, which should happen if Earth were actually rotating to the east. Everything in the inertial reference frame should be experiencing a 15 degree per hour deviation to the west. So here's another drone demonstration. This is put into ATTI mode, which is attitude mode, not governed by GPS. This is a 20-minute time lapse of the drone hovering and not deviating to the west. In fact, it's not deviating at all. It's landing almost exactly from where it took off from 20 minutes ago. The drone is in the inertial reference frame. So if the Earth were actually spinning underneath it, it would observe an actual deviation, which is what we observe in hurricanes, cyclones, and tornadoes. We view these things in the inertial reference frame, just like this drone. The rotating reference frame is actually spinning underneath it, just like hurricanes, cyclones, and tornadoes. They are actually spinning. This is not Coriolis, ballers. This is an actual rotation of something, and it's not the globe. And this is not Coriolis. This is an actual rotation of something, an actual force seen in both reference frames. So if we never observe Coriolis in balloons, in helicopters, and in drones, where can we observe Earth-based Coriolis? Well, some would assert that the celestial bodies are not moving. It is the Earth moving under celestial bodies, like the sun, the moon, and the stars. They aren't rotating. It's the Earth rotating underneath them, right? So once again, if we are observing from the rotating reference frame, things in the inertial reference frame, like the sun, appear to deviate. But they're not actually deviating, are they? Just like the assertion that the Earth rotates underneath the sun, the moon, and the stars, causing these things to apparently deviate, not actually deviate. So, if we observe these things, the sun, the moon, and the stars, which are already in the inertial reference frame, from the inertial reference frame, they should never, ever move, because it's the Earth turning under them that's making the move, right? But this view is from a drone in the inertial reference frame, viewing the sun, which should also be in the inertial reference frame. This sun should never, ever observe to move. But as you can see, the drone gets higher and the sun disappears. This is because the sun is actually moving, not the Earth underneath it.
This globe will never spin again.